So I have in my hand here a wooden splint, piece of wood. I'm going to break it up into some smaller pieces so you can see that there are now smaller pieces of wood. That will be a physical change. I haven't changed the nature of the material itself. It's just smaller pieces of wood. As the dry ice sublimes, that is a physical change. On the other hand, if I held the wooden splint in the candle flame, what's happening here, the combustion while that's burning, that's a chemical reaction. The atoms are recombining to form other molecules. We're getting carbon dioxide, water vapor, ash, heat, and light. We're actually changing the nature of the material itself. Well, let's look at that again in another way, another property of carbon dioxide. Also, the candle flame, as that's burning, that's a chemical reaction. So I'm going to ignite this wooden splint. You may have noticed that I put a few pieces of dry ice in this beaker when I started working with the dry ice. Now, carbon dioxide gas is colorless. It's also heavier than air, but we can't see it. So we'll do a chemical test to find out just where the carbon dioxide is in that beaker. It's apparently right at the very top of the beaker. It's got it completely filled up, even though you can't see it. Well, let's look at another reaction here. I have in my hand some magnesium ribbon. It turns out that magnesium is more chemically reactive than carbon, and once I get this ignited and put it down in the beaker of carbon dioxide, the magnesium actually pulls the oxygen away from the carbon, and it keeps burning down inside. Well, we've got a little bit left here. Let's get that going. And if you examine the inside of the beaker, you would actually find some little bits of carbon that were left over, and that will just keep burning all the way down inside there. Well, let's continue with